Good morning, all of you. Welcome to Vishnu's lectures. So, in today's concept, we are going to discuss about function mapping, why execution always starts from the main function, and can we execute program without main function. So, all these concepts we are going to discuss today. First, we'll discuss what is function mapping. See here, this is my program. What is my program name? Let's say prog.c. What is your step one? Step one is you have to write the program. So this is my program. How many functions I wrote? Main function, fun function, fun1 function, and fun2 function. So now execution starts from the main function. I will tell why execution starts from the main function, but as of now consider execution by default start from the main function. Now how function mapping happens, I will explain. See, so control start executing from the main function here. So what is the first statement going to be executed? In main. So first in main will be executed. After executing in main, next statement. What is this next statement going to be executed? This is function call. The syntax is treated as function call. Which function call it is? Fun1 function call. So when fun1 function call happens, control jumps to fun1 function definition. So is there any pending statements in main function? Yes, this is the pending statement, but this is executed after when you return back to this function. Getting my point? So here, whenever function call happens, it means that go to that function definition and execute all the statements. Who calls this fun1 function? Who calls this fun1 function means main function. So technically, main is calling the fun1 function. That's why with respect to main and fun1 function, main is treated as calling function. Main is treated as calling function. Fun1 is treated as called function. Main is treated as calling function. Fun1 is treated as called function. So now when fun1 function call happened, control jumps to fun1 function definition to execute all the statements. How many statements in fun1 function definition? Tell me. 1, 2, 3 statements. So when it jumps to fun1 function definition, now it will execute first statement printf in fun1. Next, it will execute this statement. What is this statement? Fun2 function call. So when fun2 function call happen, control immediately jump to fun2 function definition to execute all the statements. But there is one pending statement. Printf hello is not yet executed. So when fun2 function call happen, immediately control jumps to fun2 function definition. Now in fun2 function definition, printf in fun2 will be executed. Next, printf apple will be executed. Is there any pending statements in fun2? There is no pending statements. Yes or no? So it will return back to the same point. When fun2 function definition execution is completed, then it returns back. Where it returns back? Returns back to the calling function. When it's all the operations are completed, it returns back to the calling function to the same point. From this point only it goes. After completing, it returns back to the same point. So with respect to fun1 and fun2, which is calling function and which is called function? Fun1 is calling function and fun2 is called function. Getting my point? So when fun2 call happen, control jumps to fun2 function definition and execute all the statements. And after completing this, it returns back to the same point. Is there any pending statements now? Yes. What is that? Printf hello. So hello will be executed. After executing hello, is there any pending statements in fun1? No pending statements. So no pending statements means it times to return back. Where it returns back? Who calls fun1 function? Main function. So after completing this function definition, it returns back to the same point. It returns back to the calling function. Fun1 ko calling function is main function. So it returns back to the calling function. Now the point is here. The control is staying here. Is there any pending statements? Yes. So what is that? Printing boy from main. So boy from main will be executed. After executing boy from main, is there any pending statements? No. So main function definition is completed. When main function definition completed means your program completes. I hope clear function mapping. What is the meaning of function mapping? When function call happens, function jump to that called function definition and execute all the statements. Getting my point? Okay. See here. What is your step one? Step one, you have to write the program. After writing the program, what you will do? You will save the code. What is your file name? Let's say prog.c. Where it will be saved prog.c? In secondary memory. This prog.c is in which format? This is high level program. Whatever you wrote is high level program that is present in .c file, prog.c file. Okay. See here next. So what is step two after writing the program? In step one, writing the program and save the file. Which file? Prog.c file. The prog.c file is saved in secondary memory. That is your step one. What is your step two? Step two is compilation. GCC space prog.c. I already told in previous class, compiler having some stages, preprocessor, translator, assembler, and linker. I told about all preprocessor, translator, assembler in our previous classes. And what linker will do? I'm not discussing what preprocessor, translator, and assembler will do because this is already covered in our last classes, right? But what linker will do? Linker creates startup. Linker creates startup. What startup contains? Startup contains by default main function call and it contains proper exit procedure. Linker automatically generate startup. Whenever you compile at step two, this is step two. Step one is your program writing is your step one. Step two is compilation. So in step two, what linker will do? Linker creates this startup function. What's it? This startup by default contains main call and it having some proper exit procedure. This much clear? So now tell me, after this compilation, what happened? What is generated? After linker stage, what is generated? Executable file or a.out. This a.out is combination of data segment and text segment. So after compilation, what is generated? A.out is generated. What this a.out contains? This a.out is in binary format. What this a.out contains? This a.out contains same information, this code only. How many functions you wrote? Main function, fun1 function, fun2 function, all these functions are available in a.out now in binary format. But one more important point here, in a.out, one more function is added, that is startup function. Now tell me, in a.out, this startup function is available or not? Yes. In which format? Binary format. Now tell me, as of now in a.out, how many functions are there? How many functions are there? Main function, fun1 function, fun2 function, total 3 functions, and also startup, total 4 functions. You wrote only 3, but one extra function added at linker stage into a.out. Now total 4 functions are there in your a.out. Yes or no? So where this a.out will be stored? By default, it will be stored in secondary memory. So 2 steps done. Compilation is your second step. And at the time of compilation, the startup is added at the linker stage. So startup is created by the linker. It is a function, default function. So now after linker stage means after compilation, a.out is generated. And this a.out is a combination of data segment and text segment. And this will be stored in secondary memory. Now what do you have to do? You have to load this into RAM by writing the command /a.out. This already we discussed. So this will be loaded into RAM. Where exactly? Into text segment. So your entire code a.out, This a dot out will be now loaded into text segment. Now what this text segment contains: main function, fun1 function, fun2 function definition, and startup also. Getting my point? Yes or no? So now our fourth step is execution. So I am discussing execution clearly in next page. See the next page. Consider this complete box is text segment. See here, this text segment I'm writing in a big box in next page. This complete text segment consider here. This is complete text segment. So what text segment is contains now? The loaded program. What loaded program contains? Loaded program contains startup, main function, fun1 function, fun2 function. Sir, startup I didn't wrote now, sir. Why it contains startup? Startup, you know, didn't wrote, but startup is generated at linker stage. At the time of compilation, automatically linker will be generated this startup. Getting my point? Now all these functions are in text segment. And very important point, whenever it is in text segment, means it is in memory, means it is in RAM. If it is in RAM, every statement having some address. See, startup function is located at 00, just for example, 0000 location. And what startup contains? Main function call. This is a statement, and main function call ka address is 0001, and exit function call statement ka address is 0002. And main function is located at which location? 100 location. Fun1 is located at 200 location. Getting my point? Now it's time for execution. Who will execute? CPU will execute. So who is the first person? Which function is going to be activate first? Startup function, main function, fun1 function, fun2 function. Which function going to be activate first? Startup is going to be activate first. And what startup will do? It will call the main function by default automatically. So when main function call happen, control jumps to main function definition. And very important point here, name of the function represent address of that function. Means in place of MAIN, what is replaced? 100 is replaced. What is the meaning of this? Jump to 100 location, because main function is located at, main definition is available at 100 location. When main function call happen, control jumps to main function definition for execution. Who calls main function? Startup. So that's why technically with respect to startup and main, startup is treated as calling function and main is treated as called function. Getting my point? So now control jumps to main function definition. Now executing the statement at 101 location. See here this side, CPU right side. What is this PC? This PC is program counter. What this program counter contains? Program counter contains address of next instruction to be executed. Means consider if program counter contains 000, then 000 instruction will be executed. If this program counter updated with 0001, then CPU executes 0001 instruction. If this program counter contains 0002, then 0002 instruction will be fetched and executed. So what program counter contains? Program counter tells to CPU which instruction to be executed further. Means program counter contains address of next instruction to be executed. Getting my point? So when main function call happen, control jumps to main function definition. Now program counter will updated with 101 location. So this 101 location, this printf will be executed. Next program counter will be updated with 102 location. So CPU will execute 102 location ka instruction. So now fun2, what this fun1, sorry, this is fun1. So this is fun1 call. Where fun1 is located? Fun1 is located at 200 location. So name of the function represent address of that function. So in place of fun1, 200 will be replaced. So when this fun1 function call happen, control jumps to fun1 function definition to execute all the statements. So now fun1 is the called function, main is the calling function with respect to main and fun1. Now control jumps to fun1 function definition. Now printing printf in fun1, and next fun2 function call happens. Fun2 is located at, the statement is at 202. Fun2, name of the function is Fun2. Fun2 is located at 300 location. Definition is available at 300 location. So name of the function represent address of that function 300. So now when function call happen, control jumps to function definition to execute all the statements. Getting my point? So when it jumps to Fun2 definition, printf in Fun2 will be executed, apple will be executed. After executing these two statements, control returns back to the same point. When no pending statements, then control returns back to the same point, means it control returns back to the calling function. Who called if fun2 means fun1, so that's why fun1 is calling function, fun2 is called function here. So when fun2 function is executed, it returns back to the same point here. Is there any pending statements? Yes. What is that pending statement? Hello. So hello will be executed. After printing hello, is there any pending statements in fun1? No. Now it times to return back. Where it has to return back? Where it comes from? Same point it has to return back to the calling function. Yes or no? Now you are in main function. Is there any pending statements? Yes. That is printing boy from main. So boy from main will be printed. After printing boy from main, is there any pending statements in main function? No pending statements, so it times to return back. Where it has to return back? From where it comes? It comes from startup, so it returns back to the calling function, this point. And is there any pending statements? Yes, that is exit. So exit executed, so your program will be exited. Now I hope you clear why always execution starts from main function means because in startup main is called. Always startup is calling the main function. That's why always execution starts from main only. If startup is not created, then main will be not called. Getting my point? Why execution always start from main means because in startup main function call happen. Who create that startup means linker at the time of compilation. I hope this much clear. Next, shall we write program without main function? See, I'm writing program here without main function. Let's see what happened. I'm writing f1 function definition and calling f2. F2 is available here, f2 function definition. So basically I'm writing two functions here, f1 function definition and f2 function definition. Here what happened, see, even though if I write only two functions without main function, see here at the time of compilation, preprocessor, translator, assembler and linker, by default startup will generated or not by the linker. Even though if you wrote only two functions without main function, you have to compile it. Whenever you compile it, these four stages are involved in the compilation. And what linker will do automatically? What linker will do? Linker will create this startup function. And what startup will do? Startup will call main function. This linker don't know you are writing main or not. Always linker is going to be created startup. Always startup is calling the main function. Linker don't know you are not writing main function. That's why by default it creates startup automatically. That is the linker behavior. So what startup is doing? Startup is trying to call main function. So you are trying to jump into main function, but you didn't wrote main function. This is a conflict. Getting my point or not? Yes or no? This is a conflict or not? By default, linker creates startup. Startup automatically main function. So startup is calling the main function, but you didn't wrote main function. Your control trying to jump into main function definition, but main function definition is not available. This is a conflict which leads to linking error. Not able to link with calling function to called function because definition is not available. Only call is available. This leads to linking error. How to avoid this? How to avoid this? Simply have to inform to linker, don't create startup because I am not using main function. That you have to tell to the linker. Getting my point? So how to tell this point to the linker? By using this command gcc space hyphen no start files. whenever you compile the program by using gcc space hyphen no start files, linker will not create startup function. If linker not create startup function means there is no main function call. By default, whatever the functions you took, that are going to be executed. But you have to tell to linker, if you are not using main function means you have to tell to linker don't create startup function, because startup going to call main function. But I am not writing the main function. That's why what you have to tell linker don't create start files by using this command. If you compile the program by using this command, then linker will not generate startup function. If linker not generate startup function means there is no main function call. Getting my point? So is it possible to write the program without main function? Yes, it is possible. It is possible to write the program without main function. But if you are writing the program without main function means you have to tell to the linker, means compiler don't generate startup file. How to tell this point? By using this command gcc space hyphen no start files. Whenever you use this command, linker will not generate startup function. Getting my point? So we'll see this practically. See here, without main I am writing the program. F1, F2, no main function. Even if you are not writing main function, at the time of compilation, automatically startup will be generated by the linker, and startup automatically calls the main, and startup is expecting the main now, but you are not writing main function definition. See here, just I'm compiling this gcc space no main.c. See the error. See the error clearly here. What is the error? In function start, undefined reference to main, because startup is calling the main function, but it is not getting main function definition because you didn't wrote the main function. So what you have to do? You have to inform to the linker gcc space no main.c. What is the command? Hyphen no start files. See here, now there is no error. Now entry symbol start default to 00001050. So this is the fun1 function definition. So this fun1 function definition is available at 1050 location. Means this fun1 is at 1050 location. This is at 0000001050 location. So default entry start from this definition. This is the meaning. I hope you are clear with this class. So finally, you know what is function mapping. When function call happen, control jumps to that function definition and it will execute all the statements. And is it possible to write program without main function? Yes, it is possible, but you have to compile the program with no start files. I hope this much clear. Thank you.